In this video, we are going to learn about the inverse of a matrix. We are going to start by learning about what an inverse is and why it's helpful. Learn a quick and easy formula for finding the inverse of a 2 by 2 matrix. We'll learn how to solve systems of equations using the inverse and then do an applied problem. First of all, let's talk about what an inverse is. The inverse of a matrix is a matrix that when we multiply it together, we get the identity matrix. And we've seen things like this with numbers. For instance, if I have the number 2, what number would I have to multiply by 2 to get 1? Well, the number would be 1/2. Those two numbers here, they are called multiplicative inverses. And so we have the same thing with matrices. Here's an example. Suppose I have these two matrices, matrix A, matrix B. Let's take this first row times first column to get this element here, row 1, column 1. We're going to have 4/11 times 2, that's 8/11, plus -3/11 times -1, so that's 3/11. 8/11 plus 3/11, that's going to be 11/11, or 1. If I take row 1 times column 2, so row 1 times this column, I'm going to have 4/11 times 3, so that's going to be 12/11, plus -3/11 times 4, that's going to be -12/11, that's going to be 0. Row 2, column 1, I'm going to take row 2 times column 1, so 1/11 times 2, that's 2/11, plus 2/11 times -1, that's -2/11, I end up with 0. And then finally, row 2, column 2, taking this row times column 2, I'm going to have a 1/11 times 3, so that's 3/11, 2/11 times 4, that's 8/11, 3/11 plus 8/11 gives me 11/11, or 1. These two matrices, when I multiply them together, they give me this identity matrix. We call that I, or I sub 2. Notice we have 1s along the diagonal, 0s everywhere else. So that's a special matrix. How is this matrix helpful? Let's think about what we're trying to do. One thing we're going to want to do is we're going to want to be able to take a system of equations that's expressed in terms of matrix multiplication and solve it using the same sort of techniques that we would use in regular algebra. So in regular algebra, if I had an equation like 2x equals 7, what I would do is I would take and I'd divide both sides by 2. But we can't do that same thing in matrix algebra because we don't have division. Notice we have not talked about division at all, and there's a reason. Think back to matrix multiplication. Remember how you're taking the rows of the first matrix times the columns of the second matrix? That would be really complicated to try to undo, and that's what division does. It'll undo multiplication. We don't have this same path. We can't just divide both sides by matrix A because we don't have division. However, if we think about this differently, so let's not think about it like that. Let's think about it like this. 2x equals 7. What we could do is we could multiply both sides by the multiplicative inverse. If I multiplied both sides by the multiplicative inverse of 2, that would be 1/2. So I'm going to multiply both sides by 1/2. Then these two numbers together just give me 1, and I have 1x equals, that's just 7/2. That gives me x equals 7/2. I can't do division, but I can multiply by that inverse. That's what we're going to do here. We're going to multiply both sides by the inverse. Let's look at this and do this step by step. What I have is ax equals b. And remember, all of these are matrices. Doing something like this, that is illegal because there is no division. We cannot divide matrices. What we can do is if A has an inverse, so if A inverse exists, and that's not true for all matrices, but if A inverse exists, what we could do is we can multiply by A inverse. If I have AX here, I could multiply by A inverse. And if I have B over here, I'm going to multiply by A inverse there too. Now, one thing to notice is with numbers, it doesn't matter what order I multiply in, but with matrices, it does. So if I'm going to multiply on the left on this side, so see how I multiplied on the left? This is to the left of A. I have to multiply on the left on this side. When I take a number or a matrix and times it by its inverse, this gives me the identity matrix. So this gives me I times my matrix X. And what I have over here is A inverse B. And remember, when I take I times X, I is just a matrix that when I multiply it, you get the same thing. That just gives me X. Our solution to an equation like AX equals B is going to be X equals A inverse B. We have this method of solving equations in a new way, but we haven't talked at all about how do you find these inverse matrices. Let's look at that. Consider this matrix here. We have A equals 2, 3, negative 1, 4. And our goal is to figure out what matrix that when I multiply by that new matrix gives me the identity matrix. And finding this matrix is fairly easy because we have a 2 by 2 matrix. There's a nice quick and easy formula strategy for finding it. The bigger it gets, the harder it becomes, and so we use technology if it's anything besides a 2 by 2 matrix. Also, one thing to note is that we are only going to be able to find inverse matrices if A is square. For instance, A has to be like a 2 by 2 or a 3 by 3 or a 4 by 4. If A is a 2 by 3, this is not a square matrix, so I won't be able to find the inverse. Before we look at the formula for finding the inverse, we need one more little formula, and that's called the determinant. The determinant, if I have a 2 by 2 matrix here, A, B, C, D, the determinant is A times D minus B times C. So notice it's like a product of those diagonals and then you subtract. We talked about how not all matrices have inverses, and it turns out that a matrix is only going to have an inverse if that determinant is not 0. If the determinant is 0, then our matrix does not have an inverse, and the system of equations that your A is associated with is either going to be inconsistent, have no solution, or it'll have infinitely many solutions. To find the inverse, once you know the determinant of a 2 by 2 matrix, we have this little pattern here. Notice that these two numbers, the A and the D, they were swapped. Also, notice that these two numbers, the B and the C, they were negated. Let's go back to the matrix that we were looking at a minute ago, and let's find the determinant of that. So we're going to take 2 times 4, which gives me 8, minus 3 times negative 1. That's going to be 8 minus negative 3. That's 11. Our determinant is not 0, so that tells us A inverse exists. And our inverse matrix is going to have 1 over that determinant. And then we just have to take our matrix A here and do that swap and negate. The two numbers I swap are these two numbers. I'm going to swap those two numbers. So that's going to be 4 and 2. And the two numbers that I negate are these two numbers. Now, when I negate them, I just change the sign. I don't make them both negative. I just change the sign. So this was negative 1, so now it's going to be positive 1. This was positive 3, that's going to be negative 3. My inverse matrix is, if I multiply the 1/11th in, is going to be 4/11ths, 1/11, negative 3/11ths, and 2/11ths. And if you did that multiplication of this matrix times my A matrix, we should end up with the matrix 1, 0, 0, 1. And we did that at the beginning of this video. Now, remember we said that if we have matrices that are larger than 2 by 2, it gets really complicated finding the inverse. And so we use technology. Here's a matrix B, and what I want to do is I want to find B inverse, and we're going to do that by first inputting our matrix B into our calculator. Second, we're going to go back out to the home screen. Then we're going to get the name of our matrix, and we're going to press that X inverse button, and that's going to give us B inverse, which is our inverse matrix. Oftentimes, we're also going to need to put this in fraction form And so we're going to convert it to fraction form by using our math menu. Let's see how that works.
In order to find the inverse of a 3 by 3, 4 by 4, anything bigger than a 2 by 2, what we're going to do is use technology. So we're going to use our graphing calculator. So the first thing you're going to want to do is take and input your matrix B into the matrix in your calculator. So I'm going to press my matrix menu, so second X inverse. I'm going to go over here and I'm going to choose to edit matrix B. My matrix B is a 3 by 3 matrix, so this is correct. And we want 1, 4, 2, negative 3, 1, 0, 2, 1, 1. So there's my matrix B. I'm going to quit out of here by pressing second mode. And then the next thing I'm going to do is I'm going to grab the name of the matrix by going to this matrix menu. So second matrix. I just inputted that into B, so I'm going to grab my B. Notice I'm not on this edit menu, I'm on the names menu. And then I'm going to press this button, this X inverse button, to tell the calculator to calculate the inverse. So that looks like a to the negative 1, and when you have a matrix here instead of a number, it calculates the inverse. So here's my matrix. Notice we can't see the whole thing, but if I scroll to the right, I can see the other numbers. It would be nice if I could have these numbers in fraction form, so the way I do that is I press the math button and I tell it to convert it to fraction form. And so there is my matrix. I still have to scroll to the right to see everything, but here is the B inverse.
Let's look at a problem that we rewrote using matrix multiplication in a previous video. So remember, if I have a system of equations where I've got two variables and two equations, I can break that up into a coefficient matrix times my variable matrix equals my right-hand side. My coefficient matrix, it's going to be my coefficients of my x and y, so that's going to be 1, 1, 2, 1. My variables are x and y here, and my right-hand side is 7 and 11. So this is my matrix A, this variable matrix is my matrix X, and my right-hand side is my matrix B. So what I want to do is I want to solve. So if I have AX equals B and I'm trying to solve for X, what I can do is I can multiply both sides by the inverse of A. Notice here that my A inverse, I multiplied on the left side both times, because with matrix multiplication, order that you're multiplying matters. When I take A inverse times A, that just gives me I times X, and I times X is just X. We can easily calculate what our A inverse is. All I need to do is I would need to calculate the determinant. The determinant of this matrix, I'm going to have 1 times 1, which is 1, minus 2 times 1, so 1 minus 2, that's negative 1. So our determinant exists. We can calculate our inverse by, we're going to have 1 over negative 1, that's this part here. We're going to swap these two numbers, so they're both 1s, so they're still going to be both 1s. And these two numbers we're going to negate. So it's going to be negative 2, negative 1. So if I take this and combine that, I'm going to end up with the matrix negative 1, 1, 2, negative 1. And I'm multiplying by 7, 11. This is going to give me my solution to this system of equations. So if I multiply those two, I'm going to have negative 1 times 7, that's negative 7, plus 1 times 11, so it's negative 7 plus 11. So my x value is going to be 4. And then I have 2 times 7, that's 14, plus negative 1 times 11, so that's minus 11, that's going to be 3. So my x is 4 and my y is 3. Let's look at an applied a problem that goes with this. Suppose at a carnival, a total of T tickets were sold on one day, which resulted in ticket sales of $R. So that's unusual how we're given that information. Notice it doesn't tell us exactly how many tickets or exactly what our revenue is. It gives us it to us in variables. The cost of a child's ticket is $5, adult ticket is $15, senior is $10, twice as many children's tickets as senior tickets sold on that day. We're supposed to report a formula for the number of children, adult, and senior citizen tickets that were sold. Do not report around any numbers. Report things as fractions. This looks like one of those problems that we're solving a system of equations, and the first thing we always did with those is we identified what our goal was, and our goal is to find how many children's tickets, how many adult tickets, and how many senior tickets that are sold. So my x, I'm going to make this be the number of children's tickets. My y is going to be the number of adult tickets, and my z is going to be number of senior tickets. Now let's report the system of equations. So we have a couple of types of information here. We have the information about the number of tickets. We can organize that, or we've written this equation a bunch of times, so we could probably just do it. X plus y plus z. Instead of equaling a specific number, it's going to equal t for the number of tickets sold. This is a formula based on the number. We're also going to have a formula based on the revenue for that day. So the revenue, each child tickets cost $5, so we're going to have 5x revenue from children's tickets, 15y from adult tickets, and 10z from senior citizen tickets, and this is going to total to r. And then our last formula is a relationship. It says there's twice as many children's tickets as senior citizen tickets. The children's tickets, this is the bigger number. The senior tickets, this is the smaller number. And when we see that word twice, that usually means we're going to multiply by 2. So we're going to multiply this smaller number by 2. Children's tickets is x. Senior tickets was z. This is the smaller number. I'm going to multiply that by 2. So our relationship equation is given by x minus 2z equals 0. If we take that and we rewrite that in terms of matrix multiplication, this is what our multiplication looks like. I'm going to think of this as my a, this is my x, and this is my b. What I have is ax equals b. If I want to solve for x here, all I have to do is multiply both sides by a inverse. And since I have a on the left, I need to multiply by a inverse on the left. When I multiply a inverse times a, that just gives me I. So ix is a inverse times b. I times x is just x. So my solution here is going to be given by a inverse times b. All I need to do is find what that a inverse is, and I'm going to use technology to find that. Here's my a inverse matrix. Remember, my b matrix is given by t r0, so if I multiply these, I'll get my x. When you multiply, remember you're taking this row times this column. We're going to have 1.2t minus 0.08r plus 0 times 0.2. This next row times that first column gives me negative 0.8t plus 0.12r plus 0 times 0.2. And then the last row multiplied by that column gives me 0.6t minus 0.04r. This gives me my x, y, and my z. So the formula that we have for our number of children's tickets is 1.2t minus 0.08r. So if I know t and I know r, I can figure out how many tickets I had. For the adult tickets, I'm going to have negative 0.8t plus 0.12r. And for my children's or senior citizen tickets, I'm going to have 0.6t minus 0.04r. Now, one thing that might seem confusing is it sort of seems like you might have negative values, and you won't necessarily, because this is just a formula where two numbers are subtracted. Like if I look at this one, two numbers are subtracted, that doesn't necessarily mean our answer is negative. And in fact, if we had, like for instance, if I had t equals 150 and r was equal to 1750, then I could come up with specific values. Then my x would end up being 40, my y would end up being 90, and my z would end up being 20. You can try that out, plug it in. But this gives us a formula for how many of each type of tickets we have if we know the value of our t and the value of our r. Thanks for watching this video.